So in this video, we're going to be talking about how do we find zeros and how do we find solutions algebraically. And one of the methods that we're going to use is the square root method. So before we talk about one of these methods, we're going to talk about, well, what are we finding? Okay, so remember we're finding zeros, and zeros is just a fancy word for the x-intercept. So in this case, if this was like my function, I would be finding these 2 points right here. So I'd be finding the x value here when y equals 0. So that's what makes these 2 points important, because it's the x value that I can plug in to get out a function value of 0. So in this case, I have 2, and this is usually the case most of the time. But a lot of times you're going to have a function that only hits the x-axis once, so you only have one solution in this case. And sometimes it never hits the x-axis, and so you have no, you actually have no solution here. It doesn't ever hit ever. So in this case, you'll be dealing with that a lot in Algebra 2 and so forth. So for right now, most of our cases, basically pretty much all of our cases in this class right now are going to look like the first and the second up here. So let's talk about how we are going to find those algebraically. So the first method that we're going to use is the square root. So this method only really works when you only have an x squared. So if you had an x squared and an x, it's really not going to help you out because you won't be able to just isolate x. But here, in these two cases right here, I only have an x squared right here, like an x squared right here and an x squared right here. So I can solve here for x by using my inverse operations, and one of those inverse operations is going to be square root. Okay, so in this first example, I'm finding the x-intercept. So remember, the x-intercept means that my y value is 0. So I'm going to plug in a 0 for y. And then I'm going to go ahead and use inverse operations, and I'm going to solve this out. So the first thing that we're going to do is think to ourselves, well, the first thing I did was square it, then I multiplied it by 1/3, and then I subtracted 27. So we're doing inverse operations, so the last thing that happened has to go first. So the last thing was minus 27, so I'm going to add 27 to both sides to get rid of that. And so now you have 27 is equal to 1/3 x squared. And then the next thing that we're going to want to do is get rid of this multiplying by 1/3. So you can multiply by the reciprocal to get rid of that. So if I multiply this by 3, then this will go away, and you have 81 equals x squared. And now we need to solve for x by undoing the squared. And the way we're going to undo the square is by taking the square root of both sides. So if I take the square root of 81, so one of the answers we know is 9. But the other answer that people always forget about is -9, because if I do -9 times -9, well, it's going to become a positive 81. So yes, there are two answers every single time you take a square root. So my answer is going to be x is equal to 9 and x is equal to -9. Now, a fancier way to write this, instead of writing two different answers, is just to say that x is equal to plus and minus 9. So just equals, I forgot my equal signs, equals plus and minus 9. That's just a fancier way to just kind of put that all together. So now we're going to go ahead and check our answers. So we were finding the x-intercept of 1/3 x squared minus 27. So a quick way to check your answers is just to graph it. So I graphed the function right here. This is 1/3 x squared minus 27. If you look here, one of the x-intercepts is -9 and the other one is 9. So I did this correctly. All right, so now let's go ahead and do the next example. So for the next example, I'm not finding an x-intercept. I'm not finding when y is 0, but I'm going to find when y is 5, when f of x is 5. So we're going to do the same thing, but the only difference is that instead of putting a 0 here, I'm going to go ahead and put a 5. So 5 equals x squared minus 7. And then we're going to add 7 to both sides. 7 plus 5 is 12. And then I'm going to go ahead and undo the squared by taking the square root. So now, The 12 is not a perfect square, so it's not like 81 where it had a nice integer answer. So what we learned how to do with this was that we learned how to simplify it. What perfect square does go into 12? So let's think about our perfect squares. Remember those numbers that we can actually take the square root of. So one of them is 4. We can actually rewrite this as the square root of 4 times the square root of 3. Well, what's the square root of 4? I know the answer to that. It's 2. So my answer here, remember when I'm dealing with square roots, I have two symbols. I have plus and minus 2 square root 3. So this would be the nice simplified version. Again, the answer could be plus and minus square root of 12, but this is the way that you would see it, especially like if you had like a multiple choice question, because this is the simplified version of that. Okay, and then obviously if you looked at the graph of this for when you got out of 5, what's going to happen is going to be like a decimal value that is equal to 2 square root 3. So now let's go on to the last example. So in this case, I'm trying to find the zeros. So zeros, again, is just a fancy word for x-intercept. It's the value of x when y is 0. So let's make this into a 0. And let's do our inverse operations and solve. The first thing that I'm going to do is I'm going to get rid of that minus 4. Right? So let's think of ourselves in order what's happening here to x. First I subtracted 1. Then I squared it. Then I multiplied it by 2, and then I subtracted 4. So we got to get rid of the last thing first. It's inverse. So I'm going to go ahead and add 4 to both sides. And now you have 4, 2x minus 1 squared. Then the next thing that I got to get rid of is dividing by 2. This multiplying by 2 by dividing by 2. And I have 2 is equal to x minus 1 squared. Now in this case, taking the square root is not the last step. It's the second to last step. So let's go ahead and get rid of that squared because that has the x and the minus 1 in it. We're going to take it by taking the square root of both sides. So you cannot simplify the square root of 2, but remember that the square root of 2 has 2 answers. So I'm going to put a plus and a minus square root of 2. And I have x minus 1. And now the next thing we have to do is get rid of the minus 1 by adding 1 to both sides. And so I'm just going to put a positive 1 here. So my answer is going to be 1 plus the square root of 2 and 1 minus the square root of 2, because one of the answers for the square root was positive 2 and the other one was negative 2. So, but the easiest way to kind of write this is that x is equal to 1 plus and minus the square root of 2. So again, this is just like 2 answers written on 1. Okay, so this is the end of this video, and I hope that you found this helpful.